is Aris from Ulap, and today I'm going to spend a few minutes going over an overview of CERA, which is our secure ML inference engine. So CERA has been architected and follows the DoD DevSecOps reference architecture and was jointly developed in support of the mission requirements provided by the US Cyber Command and US Army Cyber. CERA has also undergone CDSO set of scans as well as penetration testing by a third party within the DoD. So currently today, CERA enables users to locate, register, and deploy open source machine learning models, large VLLMs, as well as custom frameworks. CERA provides users with the ability to deploy fully trained and hardened models into IL5 environments. The models that can be deployed within CERA are automatically auto-scaled and also load balanced. Now I will provide you a quick overview and a demonstration of how CERA works. This is a landing page once logged into CERA that displays the currently registered models as well as the actively deployed inference engines or VLLMs inside of the application itself. There's also a section that has heavy integration with Hugging Face, which CERA has the ability to automatically pull and deploy models that are located there. So there's deep integration between the open source models that exist that could be used quickly to test within IL4 or within your development environment. Once the models themselves are vetted, and once the data scientist actually evaluates that this is the model that they want to work with, that model itself can be registered and then pulled into a private repository that CERA uses, at which point they can continue to fine-tune, iterate, and train the models themselves. CERA has full integration with MLflow model registry. In the upper left-hand corner here, you could see a button that can be clicked, which will ultimately take you to any model that has been registered within CERA, that has been pulled from Hugging Face, or manually custom models that have been developed internally that can also be published, where experiments and models can be tracked over time and their life cycle can be evaluated. Now, if we wanted to show and demonstrate how easy it is to do one-click button deployment of current models that are located in the open source, as in this example, within Hugging Face, we're going to pull up a model, a Granite model by IBM, that we want to quickly deploy and be able to kind of evaluate. So once I've located the model and this page is fully searchable, I can click on the deploy button, at which point that model will be automatically fetched and deployed within CERA. So let's go ahead and do that. Once the process of deploying is initiated, what CERA does is it automatically spins up a machine learning node, in this case, one that has a GPU and the adequate resources to be able to actually host this model and serve it. Because different models, specifically VLLMs, have different requirements. As part of the CERA application, we have gone through various different paths of evaluating the model requirements and what they need in order to be served. Now, we've deployed that, and we can come onto the landing page and we can see that IBM Granite is being deployed. While that's deploying, which takes about a minute or two, there's a couple of other things that I'd like to show you. For the models that once are registered inside of CERA, not the one-click button deployment ones, but the ones that you actually register, or the manual ones or custom ones that you develop internally, you have the ability to deploy and control on which machines those go. So as an example, if you want to deploy an inference and you click on it, you could choose from a list of models that you have actually registered within CERA. The frameworks are automatically recognized and the model folder will appear as it's hosted inside of MLflow during the initiation. The advanced settings give you a couple of more options where you can select individual GPU machines that are available in the current deployment of CERA, as well as control the resource allocations and the scaling, meaning how many CPUs should be requested, what the memory limit is, as well as the concurrency and the minimum replicas, which can dictate how many replicas of the model are actually deployed. CERA natively has auto scaling in correspondence with the concurrency of how much throughput the model is receiving. So lots of different options where you could control how the model is actually hosted and being served. Now going back to IBM Granite, I can see that it's deployed, that it's ready, and that it's running. Once a model is deployed, you would typically want to evaluate and ask it some questions. There's also a section here called Inference, at which point you can click, and there are 3 different options how you can quickly evaluate the model where you don't have to do it on the back end through the code or shell commands. You can actually do it directly from CERA. Now, as part of the payload of talking to a model, specifically a VLLM or an inference engine that's a machine learning framework, you have 3 options. You could talk to an inference that's a machine learning framework where you could upload a file with the payload. We also have prompt, which is VLLM completions, and as well as chat. So in the case of IBM Granite, we could ask it various different questions, simple ones and complicated ones, specifically potentially maybe pertaining to cybersecurity as an example. I could ask it, how is data exfiltration evaluated? Now, remember, we went to Hugging Face, we found the model that we wanted to evaluate potentially. We clicked on deploy, at which point CERA fetched it, deployed it, spun up the node that we needed in order to do that. This is a quantized model. So here's an actual response that basically tells us how exfiltration is evaluated. There's many different things that VLLMs will respond with. This is a quantized model, so it's a lot of a smaller one, so its responses can be limited. But there's many different options from a deployment perspective, how you can actually configure these models, fetch bigger ones, deploy on larger GPUs, and then as well configure the throughput that is adequate for your use case. Another thing that I'd like to point out here is that there's also a monitoring section. So in the example of IBM Granite, if I click on it, we can see that the model was deployed. We can also see that I was asking a bunch of questions. So what this page actually allows you to see is it allows you to see the metrics of the model. You could also have access to the logs to see the behavior, how it's responding to the questions that you're asking. And there's also a memory network and CPU traffic that can be evaluated, so you can actually monitor the performance, whether a bigger node is needed or if there's more fine tuning that needs to be done with the model. This is a quick overview of CERA. Thank you for listening.